Welcome to the garden. Today we're going to be taking a look at this rarest of beasts, the single phase contactor. And of course, usually you would probably use a relay for this sort of thing. This load that we've got for this, apologies for the last minute end of the world scraping the barrel screwdriver, but it's all that was available. This is going to switch a couple of amps, 3 or 4 off the top of my head, rated 20, 2 pole. Which means you've got 2 there. Single phase, you'd typically use a relay for this, but for whatever reason, we're not. The reason for that is because, sorry mum, but I read the instruction manual, or more accurately the installation manual, which means when it doesn't work, if I follow the installation manual, even if you know better, you can blame the manufacturer and they have to sort it out, not me. So, I don't think you can really... I think the reason they've specified it is because they don't know what the other half of the system is. And there's a 240 volt out, which is why we've got the 230 volt coil. And you need to match the coil to whatever your actuating signal is. And then this, the switched part of it is, in this case, live and neutral for single phase. And that's 20 amps. It's way over what we need, but it'll do. Sort of thing you would use for that sort of thing normally is one of these relays, which I found knocking around in a microprocessor box the other evening. Bearing in mind that's spelt wrong, that is very probably a knockoff from everyone's favourite purveyors of questionable origin, quality, whichever you want. 40 amps, that'll be a laugh for another day. Anyway, back to the contactor, as that's what we're doing today. Coil is the A1 and the A2, which is that and that. And then you've got one switch line, which is normally open from the signal, which is 1 to 3. Is that one? No, 1 to 2. Sorry, I was reading that bit. 1 to 2, and then you've got 3 to 4, which is normally open as well. One advantage you have with contactors over relays, apart from typically the different current range, is that a lot of, or you can get contactors that have got auxiliaries on them as well, so it's not just the load you're switching on and off. Thing to note, we've got the CE marking, conforms European, and it's correctly spaced, so it definitely isn't China engineering, or whatever you want to call it. UKCA mark, which I believe is now obsolete as of the time of recording, which is one of those things that since we Brexited several years ago now, we had to put on everything. And that's by way of getting rid of all the red tape, and particularly for things like moving things from A to B, it turns out the red tape was holding everything together. And now we've got rid of the red tape and that's all fallen apart, and now we put this on everything and we decided that we're not going to use this anymore and it's obsolete already, even though it never actually came into use properly. And we're going to indefinitely recognise the conformity European mark. Progress. As an aside, I think currently the only thing that there's a question on the UKCA is building materials or construction materials, which I believe they were going to do something about at the end of, or early start of June 2024. And then just ahead of the meeting they were having, which is something that I'm going to get updated on at some point in the not too distant future, they called, or the previous Prime Minister called a general election, and they said, oh, well, we'll wait till the next government comes in because that'll make any difference. Great. Well, let's get it wired up. Before we do, what we can do is check this coil resistance between the A1 and the A2. And I don't know if you can see that or not, or I can't even see it. 3.6k. So what's that? 240 volts, 3.6k, 230 rated over 360 is just under 2/3 carry the 10s, and that's 60 to 65 milliamps, 62.5 milliamps. That'll do. Doesn't matter which way we go in here because it's AC, so there's no polarity as such. So we'll do it this way. I'm not going to terminate it properly because I am literally just checking contactor functionality. Obviously, when I install it on the actual device, it will have correct terminations and the cables. Don't tell me. I know. I'm one of the first people complaining about that sort of thing, so I always feel really bad when I do it. But so for this, no. That's why you use them. Ugh. It did feel tight until it wasn't. Better. Right, what we'll do is we'll plug this in and power up. No bang. So nothing has failed yet. Vac, do you fit through there? Of course you don't. So we'll electrocute ourselves going in this way. 240. Okay. Then if we go into the other side, oops, there's nothing, and that is because the contactor hasn't been energized. So we'll power off. We'll do something you should never do, which is wire your over directly into the thing. Just because, again, I'm only testing it, not really interested in doing anything properly. In you go. Of course, they have very sensibly made it so that when you've got your impacty, you can't electrocute it, or you can't shove it in there with your 6mm hex. DIN mount. Oh, we should do it for proper. Let's pretend this is our electricery cabinet. And let's pretend that we have a load of other instrumentation mounted on this. Ignore those earth blocks. No idea what they're from, but it was something clearly a million years ago. Given the state of the DIN rail. Oh, God. Oh, wrong way, mate. Get in. Will do. So what you now do with your DIN rail mount is you clip Ioni, shove up, and in theory it should stay on there. And what you do to take the kit out is to, it's going to be tricky, get your screwdriver, plug it into the tab, pull out, and then get it out. I'll point out this is incredibly easy to do now, whilst it's just on this small test rig. But if you ever try and do that in the real world, in a real cabinet, you've got absolutely no hope of it working. They're just nightmares. You can never, ever, ever get them where you want them. Okay, actually that's the other way, so let's do it this way. Can't even see if that's in. I can feel it's grabbed it, so we might be in luck. Yes. Yes. Very peculiar. I noticed that these, the terminals that you're switching, i.e. 1, 2, 3, 4, they've got Posidriv 1 screws on them. And the A1 and the A2 have got what looks like a Phillips, so it's probably actually a jizz looking at the depth of it, but it's a Phillips with the crosshead, slots head, thing in them, which is absolutely criminal offence. So let's put you as the you live can go into brown because that's the same colour, even though polarity doesn't matter on AC. Get in until we terminate. And we'll just pretend that neutral is black, which it isn't. Good. So if we volts AC, DC, AC, electricery on, plugged in. So we've got 240 volts here, Now when I close this clamshell connector, what I expect to happen is that this indicator window will probably go red to say danger, I'm live, and we'll get 240-ish on here with maybe a small bit of, it was 240 when we measured the inlet, so it'll be about 240 on the outlet. Aha! We have operator error. We didn't plug in the clam connector. "10 points to anyone that spotted that," i.e. everyone. Try that again. 240. And is that red? It is. That's red. 240 volts on the way out. Single phase contactor. That's all she wrote.